In this video, we're going to be looking at how can we prove shapes in the coordinate plane. We're going to focus strictly on quadrilaterals, and what that means is four-sided shapes. So if you look at this little diagram, you can see that there are many different four-sided shapes, and we're going to take a look at most of these and some of the special properties that these shapes have to help us prove that they are that specific shape on the coordinate plane. So let's just dive right in. The first shape we're going to talk about is a kite. Now, kite is exactly what you think of when you think about a kite, and something like that. Now, the definition of a kite is a quadrilateral, so a four-sided shape, with two pairs of adjacent congruent sides, but the opposite sides are not parallel. So what that means is this side and this side are congruent to each other, and this side here is congruent to that side there. But this side is not parallel to its opposite side here. So these are not parallel. That's what makes a kite. Now, a kite does have some special properties. One of those properties is diagonals are perpendicular to each other. What this means is that if I go up to the kite here and I draw in a line from opposite angles, and I draw a line from the other opposite angle, those lines, those two diagonals, make a right angle with each other. Now, another neat fact about a kite is that not only are those diagonals perpendicular, but the cross diagonal, meaning the shorter diagonal, this one here, is always bisected in a kite. Alright, so those are the properties of a kite. That's what's going to help us determine if the shape on the coordinate plane is in fact a kite. So let's take a look at determining if RSTV is in fact a kite. We need to show that those properties that we just learned about a kite are true. So the first property that we need to show is that the adjacent sides are congruent. And the second property we need to show is that the opposite sides are not parallel. So this is going to take some thinking. How do we show that sides are congruent to each other? Well, to be congruent, they need to have the same length. To show that they are congruent, we need to show that their distance is the same. Okay? And then to show that they're not parallel, we need to show, if you remember, to show lines are parallel, they have to have the same slope. So we have to show that these lines do not have the same slope. What we have to do is look at each side of the shape. So to do that, we first have to identify all the points. So we have this side here, R to S first. So let's take a look at RS and say, okay, what is the distance of this line and what is its slope? So remember, distance formula is the square root of negative 5 minus 2, so x minus x squared, plus y minus y squared, which in this case is 7 minus 6 squared. And if you simplify that, you get negative 7 squared, the square root of negative 7 squared, plus the square root of 1 squared. And then you simplify that, and that gets you 49 plus 1, or the square root of 50. We can just leave it just as that, so it's square root of 50. And the slope is change in y over change in x, so it's just 7 minus 6 over negative 5 minus 2, which that gets you 1 over negative 7. So your slope is negative 1/7. Alright, so that is our S. I'm going to erase this a little to save us some space. Let's take a look at the others. Let's look at RV, so R to V. So if we draw a little triangle point to point, we go down and then over. So you see that it's down 7, so it's negative 7, and right 1, so positive 1. So our distance is then going to just be the Pythagorean theorem of square root of negative 7 squared plus 1 squared. And that's going to simplify to the square root of 50. And then our slope is down 7, so negative 7, and then right 1, positive 1. So our slope is simply just negative 7. Okay, let's do the same for the rest of these sides. V to T. V to T, same thing. Let's look at our slope first. So it's down 3, so it's negative 3. And then over a positive 9. So we get a distance of the square root of negative 3 squared plus 9 squared. And that gets us an answer of the square root of 89. And then our slope is going to be negative 3 over 9, or negative 1/3. So we're going to do the same with our last side, which is going to be ST. So S to T. And so if we look at that, that's going to be over 3 in the positive direction and down 9, so negative 9. So ST distance is going to be the square root of 3 squared plus negative 9 squared, which is equal to the square root of 89. And then our slope is going to be rise, which is negative 9, over run, positive 3, which that is equal to negative 3. So now when we look at each of these pieces, we can see our S is congruent to RV. We can also see that VT is congruent to ST. So that shows that the adjacent sides are congruent. And then if you look at the slopes of RS is opposite of VT. So RS is not parallel. Remember, those double bars mean parallel to VT. And RV is not parallel to ST. So this shows that opposite sides are not parallel. Okay? And that's it. Alright, let's take a look at one more example. So in this one, we're going to talk about parallelograms. So parallelograms actually have 5 special properties. And the first property is that, well, it's a quadrilateral. But knowing that it's a quadrilateral, it has 5 properties. And those properties are opposite sides, and this is where the definition comes from, are parallel. Also, opposite sides are congruent. Diagonals bisect each other. Opposite angles are congruent. And consecutive angles, meaning angles that are on the same line. So if we had a parallelogram here, consecutive angles would be this angle and this angle. Those are supplementary. To prove these properties on the coordinate plane, let's take a look at the easiest way to do this. So, is ABCD a parallelogram? The easiest way to do this is we just have to prove one of those properties to be true. If one of them is true, then they're all true. So the easiest one to prove is, are opposite sides parallel? So if we can prove that, we can prove that it's a parallelogram. So the way we show opposite sides of parallel, they have to have the same slope. So all we have to do is figure out, all right, we have side AB, what is its slope? We have side DC, which is opposite AB, and figure out its slope. A to B, there is no rise in that line, and its run is 13. So if I have no rise and I run 13, my slope is 0. Do the same for DC. There is no rise and its run is 13 as well. So the slope of DC is 0 over 13, or just 0. Now, both pairs of sides have to be parallel. So we checked one pair, let's check the second pair here. So if we look at BC, what is its slope? So rise would be 1, 2, 3, 4, 5, 6, 7. So we went down 7 and left 1, 2. That's negative 7 over negative 2. When you have two negatives, that simplifies to 7 over 2. So the slope of BC is 7 over 2. Now we have to look at what is the slope of AD. Again, all we have to do, find the rise over run. So AD, I'll start down here at D, go up 1, 2, 3, 4, 5, 6, 7, over 1, 2. So that's 7, 2, goes in the positive direction. So our slope is 7 over 2. Now, BC and AD have the same slope, so they're parallel, and AB and DC have the same slope at 0, so that means they're parallel. So, AB, CD is a parallelogram because opposite sides have the same slope, which means they're parallel. And that's it. That's all you have to do. Find the slope of each side, and you can prove that this is in fact a parallelogram. Alright, so that was a good example of proving two different shapes on the coordinate plane. In the next video, we're going to look at a few more specific shapes.